Yo, 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 gamers, what's up? I'm gonna act like a streamer. Yeah! Everyone, like and subscribe, and we're here and we're gonna play some games because we're streaming games. Okay, so here's this game, and I'm gonna play it. Yeah. Wait, maybe I'm gonna play it? Wrong one. There we go. uh, okay, okay, what are the buttons? Ah, that's it. Yes. Ha 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 ha. Best game ever. Man, I'm not very good at this game. I think that streamers are supposed to talk about the games while they're playing them, right? Yeah, so isn't this amazing? Look at the graphics on this. I bet this was written in C. I reckon they used DCC to get their code nice and clean. Oh, 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 there's a... Yes! That's how you know I'm a power gamer. Pro power gamer. I hit the UFO at the top. And... Hello, everyone. Okay. I'm gonna stop there. Go back to my slides. But I thought I should say, I thought I'd start like that just for fun. I accidentally jumped into some other slides by accident because I actually have two different cameras that I can use for other things. That's why I don't usually use them for lecturing. I'm going to assume that everyone can hear me. Okay, a couple of people have asking whether this stream's going to be recorded. Yes, the stream will be recorded. Because it's just, this is more informational than it is, like, computational theory and all that kind of stuff that we would usually be doing in our normal lectures. This one's a little bit... I mean, I am going to talk a little bit. I've got some slides even, but a lot of it's going to be like Q&A and stuff like that, and just if anyone's got any issues with the assignment and everything. I've also, like, you can see I've changed my camera angle so I can actually read the chat closer rather than my normal camera angle is over here, and it's all me focused on the slides, so now it's going to be a little bit more other things. Someone said they heard an echo. Are you still hearing an echo? Yeah. Matthew. Yeah, I should get people to donate because you're not paying enough for your uni fees already. uh, but anyway, I thought as this is an unofficial lecture, it's not a lecture, right? It's a live stream that... Oh, there's no echo now. Hopefully that's okay. There could have been because I accidentally jumped to my other setups in OBS, which is the streaming system that everyone uses. Like, most people use OBS, I think, who stream. And I accidentally jumped to other scenes where there was multiple cameras and stuff. Hamming Wang's asking how long is this going to be. It's not really a lecture. It's more of a conversation than a lecture. And I've scheduled about 2 hours. So I think it'll be about that long, but it depends more on who's here than anything else, because it's going to be a little bit based on if people have questions. What I do want to do, though, and I'll probably put this in the first half, is I do have some slides and I want to talk about the assignment in a way that gives you all the kind of official details, so that if you need them, you have them. So it's not even going to, like, the first half is not even going to have that much content. It's going to feel a little bit like a lecture, I guess. It's not going to have that much content about the assignment itself, but we're going to talk about the official stuff around it, and then we can talk about, like, ideas about the assignment. So let's launch into it, because the slides here, I think I've only got about half an hour's worth of slides, depending on how verbose I get about the slides. Ah, Dean's here. Everyone say hi to Dean. Just to let you know, the majority of the work on the assignment was done by Dean, so he actually did the kind of first implementation, and himself and a few of us who worked together on the assignment worked back and forth to decide exactly what we would ask you to do. So with your assignments, there's this combination of how we build the assignments. The first thing's always going to be, from my perspective, what do I need you to learn? So what do I want to test you on? Which skills do I want to push for you to take some extra time with so you can get really good at them? And one of those is definitely looping through arrays. And so you'll find that the majority of work in this assignment is looping through arrays, but the deeper it gets into the assignment, the weirder those loops have to be, and the more you have to think about them to get them working. Question from COMP1511. For the enter lines of stone part, do you have to make the PC vertically space automatically when the first 4 numbers are inputted? I don't think so. I think it's only going to read whatever numbers you put in, and if those numbers aren't in any particular order, it's not going to worry. Like, if you think about it, scanf doesn't know or care whether there are spaces or whether there's enter keys between the numbers, but it is just going to want to know that there's sets of 4 numbers. So every row of stones is a set of 4. Pretty sure it's a set of 4 numbers. I'll go back to the spec and check, but I'm pretty sure, yeah, and so there'll be sets of 4. And then when it's scanned, all of the inputs, because you tell it how many stones it's going to receive, so it's going to want sets of 4 numbers for each of those sets of stones, and then when it's finished receiving all of that, it'll then just start the game. Anyway, let's talk the official things here about Freefall. So, Freefall is assignment 1. So if we're going to do this from a very practical perspective and talk about what this assignment is, you are going to write a program, and it is called Freefall. It is in a file called freefall.c. Submission is through the give system, which is exactly the same as the system we've been using for your labs and weekly tests. So we're not throwing anything weird or new here in with this. The only thing that's happening is that, as opposed to a lab, it's not a small program, it's a much larger program. I mean, when you think about it, I would say this is made up of about 8 to 10 lab questions chained together, but they're all chained together in a specific way to still work with the same system, which means that some of the structure that you're going to build around it, the 2-dimensional array and stuff like that, you're going to have to put more thought into than you would with a lab. A lab's really focused on just one task at a time, but when we're doing multiple tasks in a single program, we have to make sure that they coordinate with each other correctly. So that's an important skill as well. That's a necessary skill, and so we're happy that you're getting to practice that. But the nitty-gritty, not really the nitty-gritty, but the system we've built around it is the same system that we normally use. So you've got auto tests and you've got give, but you also have the ability to do your own testing. There's stuff in there that is that helps with testing, and there's some stuff there that shows you how you can actually write a whole series of commands, like a whole series of numbers in a text file, and then just go, okay, act as if this text file was being typed into the terminal, and it works like that. Qwerty has some questions there. So if I say 3 lines and put in 12 numbers, yeah. You don't have to press enter for the 4th time, Qwerty. It just needs to have all of the 12 numbers read in. So scanf doesn't really care whether there's enters or not. It only cares that the numbers have been entered, and they don't count as being entered until the enter key has been pressed. So every time the enter key has been pressed, everything that was typed in so far gets, theoretically, in a sense, sent to the program, and the program can read whichever numbers were in that line and whatever was there previously as well. Anyway, let's go on to bits and pieces. The program will work in the same way all the time. So you can think of it as a loop that's going to keep going. I mean, this is after it starts. When it starts, as we've actually been discussing here with Qwerty, you take in the number of, hey Tom, how's it going? You take in the number of rows of stones that are going to be entered, then you enter all of those, and that builds your first map. After that, everything you receive is a command. So it's always going to be an integer, and each of the different commands that the game can receive comes in as an integer, and then it may or may not have more integers that follow on from that. So that means that some commands don't have any follow-on integers, some commands have more follow-on integers that allow us to build up some information. As you go, you will receive these commands, and basically you will process the command, and the way that Freefall works is really similar to how I was doing the demo of the tourist walking around the map, is that every command it receives, it will then show the map. So it's kind of like, after I receive this command, here's the new map and all the changes that that command made. And so every time you do it, you'll get the result, which means that you can see immediately whether your thing is working or not. One of the things we wanted to do with something like this, where it's a potentially larger, more complex things you're having to work on, we wanted it so that you could kind of see visually whether things are working or not. Because it's really much easier to debug something if you can actually just see the grid and you go, oh, okay, this is what's happening. This is why we're working on two-dimensional arrays. We could have done the whole assignment with one-dimensional arrays if we want to, with different levels of complexity. But I think it's more fun to see what's going on with the two-dimensional arrays. Also, it gives us the opportunity to do something cool, like something that acts a little bit like a classic arcade game. I have a talk, which I'm obviously not going to give now, but I don't know if I'm ever going to bother giving it at UNSW, but at some point maybe I will, which is like a brief history of computer games. So I start in roughly the 1960s, and I go through to the present, and so this era between about 1977 and 1983 is considered the golden age of arcade games, where they were huge. 1982, I think, at the peak before it started dropping off. So it dropped off around the time that home consoles started appearing, and Atari had some issues at that point as well. But anyway, 1982 was the point where the computer games industry, just with arcade games, was bigger in the US. We sort of often measure stuff in the USA because it's like one of the big consumer markets in the world, but it was bigger than both the Hollywood movie industry and the US music industry combined. So the entire US record industry and film industry was eclipsed by the arcade at that point, and that's just like a wonderful moment for computing, because that was the first point we did that. Now it's considered normal that computer games are a bigger market than any other form of entertainment, and we're just completely dominant in entertainment for humans. But back then it was a big deal. It was the first time we did it. Max is asking about style with divider comments. Dean or Tom, I think you could probably answer that one. Okay, so when we're taking in commands, we're taking information and then maybe some other information. We process it. Oops. Who copy-pasted the slides from last term's assignment? What's it called? Is it called a map, Dean? Oh, I've uploaded those as well. I thought I was careful because, I mean, the structure of the assignment's similar, so I started off with the slides from last term and then made some changes. Last time we did Minesweeper, so there's a minefield there. Okay. One thing I can say is we do take the submissions via Give. Let me just move my face so I'm not in the way. If you submit often, then we have a copy of your code, which means that if something happens, we can get your code back if we need to. I would say submit early, submit often. Your submissions don't have to work. I think we made this clear in the assignment spec as well. You can submit anything you want. We will not care if your previous submissions don't work. We're only going to mark your final submission. It's just really good practice. As I was saying in the lecture yesterday, the thing about 3 physical locations, if you submit to us, it's kind of like you have multiple different backups of different times in a different location to your own computer, so it's quite safe. So it's a good thing to do. Don't be afraid of submitting multiple times. Oh, Bitsu was just asking about that. Yeah. So you're right. Your question is correct. Yes. You can submit as many times as you want. We're not looking for only one submission. In fact, if someone only makes one submission, it's kind of like, did you not want to save this or back this up along the way? It's like we much prefer seeing someone submit multiple times. And then if we really want to, if you want to talk to us about your assignment, we can then actually with you. Yeah, Priya. Yeah, I was like, I'm always going to say good morning, and I'm always going to say yesterday for the previous lecture. That's the new terminology. Hash define previous lecture yesterday. Wait, other way around. Hash define yesterday previous lecture. What was I going to say? Yeah. So if you were to ask us advice on things and say, look, I made some changes and things aren't working anymore, we can look through and we can go, okay, let's look at your previous submission, your current submission, and help you figure that out. Good morning, David. Is indeed a lovely morning. I'm not sure why it's getting darker outside than lighter. Something must be wrong with the morning. Okay, so what I'm going to say is, like, submit as much as you want, because it's not going to hurt anyone for you to submit. I mean, it does take a little while, because when you submit, it tests all of your code. But it's kind of like you get a free auto test out of your submission. Talking about testing itself. So we have auto tests, right? The auto tests are going to poke at your program and reveal some of the things that your program is expected to do. And you can see me choosing my words carefully there. It will poke at your program, it will reveal some of the things that your program is supposed to do. That is not a guarantee that if you pass the auto tests that everything is correct. For example, we might have something that looks at whether stones are outside the grid or not. And I haven't looked at the auto tests to see for certain, but I know the way we usually do this is we might test some of the sides, but not all of them. What we're hoping is that you write your code in such a way that you are checking all four sides, that the that stones or any reference to the map might be made, and making sure that things aren't leaving the map in a weird way or something like that. But we won't necessarily auto test them all. What we're doing is we're slowly introducing to you the idea that there is no way you could ever have a universal test that knows exactly how every program should work. The only way we could ever have that is if we had the whole program already. And generally no one's going to sort of pay you to write a program if they've already got the program written. Yeah, Yifan Su is asking, so should I submit my assignment whenever I finish one section and only the last submission will be recorded? Yeah, definitely. I mean, personally, I would submit every time I finish a section of a time of work. So I work for a few hours, and I go, all right, I'm going to take a break, and then I'll submit at the end of that, because I know that that's a point where I'm not going to look at it again for a little while. And in the next few hours, what if I spill my drink on my laptop and I break my hard drive? You know, I might as well have the code somewhere else. Although, if I'm working on VLab, it doesn't matter if I break my laptop. Well, I break my laptop, that's bad. But it doesn't matter, my assignment won't get lost if I'm working on VLab as well. Oh, excuse me. Oh, you can't see that, it's behind my face. Good. Let me just, yeah. You've caught me on a Friday afternoon. All my games apps were open. Although, funnily enough, my face was covering up most of that, but Epic Games just tried to put ads up during my lecture. Okay, now I'll put my face up here instead. People are always going to ask about what kind of marks. Oh my god. Sorry, I knew I checked for some of this stuff, but I hadn't actually I'm just gonna delete this. I wonder if I've got stuff in here about... No, I thought I'd made these slides generic enough that they didn't have specific assignments in them, but I had some stuff in there about a previous assignment. Okay, so how do we get the marks for the assignment? So the assignment's going to have a range of possible marks up to the full marks of 100% for the assignment. We have set it up so that we're testing in the stages, in a sense, different levels of competency in the assignment. This is going to be a bit different from what you might expect from having done assignments in something like high school. I don't know how many people are straight out of high school, but usually I can assume that there is a majority of people in a first year of university who have come to university after finishing high school last year. The way that we might structure a university assignment is we might say that if you get a passing mark in the assignment, we consider you to be competent in the technical skills that we've been teaching you. So if we consider you to be competent in the technical skills, that means you only need to get 50% for us to consider that you can do what you need to do. Anything beyond that is interesting and useful. So we get a very different thing, and it's often, I don't know, well, you're all in your second term now. Oh wait, your first term was pass-fail. Yeah. So everyone in the first time, this is your first time getting marks from a university. I hope it's not too much of a shock to everyone that the marks will be very different from high school. So you can be someone who completed everything in high school, because in high school you are actually generally expected to be able to complete everything. As you may have noticed already from things like challenge questions, I don't expect everyone in the course to be able to complete every question that I've got in the course. Not only that, I don't even particularly want that. Like, I'm happy for people to learn less, like a lower number of topics well, than to try to cover a lot of topics and end up not understanding them all. I mean, it's kind of good in both. I mean, in first year it's okay because you're going to see all these topics later and you're going to learn more about them. But what I'm trying to say here is I'm going to go through this and talk about the different marks levels. You don't have to aim for 100%, and it's actually not. It's not really feasible for everyone to aim for 100%. I mean, some people can be like, oh yeah, I'm going to 100% this assignment. So yeah, go for it. But I want to point out that it's not necessary, nor is it even advisable if you've got a lot of other work to do. So a pass means that you've got everything that you need, and everything beyond that is sort of bonus content. So I'm more than happy if people hit a limit and they say, okay, I'm done here. You know, and people are going to see this because you'll be able to understand what you're doing, hopefully, in like stage 1, and then as you get on, so you get to stage 3 or 4 maybe, like someone's going to get to stage 4 and just go, I don't know how I'm going to do that, and they just stop and they hand it in, and it's like, that's fine. You're still potentially going to get a high distinction at that point. So when I'm talking about the marks here, I'm trying to say that like there are different thresholds that everyone can reach, and it's about where you want to be. And again, I go back to that thing I was talking about at the very beginning of this course about how your education is your own. Now you have your own options and your own choices to do what you want, so you can choose how deep you go into computing. And that's at this small scale as well. You can choose how deep you want to go into this assignment, based on how much time you have to do it, based on how interested you are to do it, and based on how much, you know, how much mental anguish and pain you want to put yourself through. So this is harder than stuff that we've been doing, well, outside of the challenge questions. Some of the challenge questions are harder than the assignment, but even then, this is like a big bulk of work, so do as much of it as you feel comfortable doing and what feels right to you. My hope, which is different from what I require from you, but my hope is that people get really interested in this assignment, because the assignment lets you build something that ends up actually being playable as a game. So my hope is that people get so excited about this that that they go really deep, and then they do everything, and they get excited, and they start emailing us other things that they've been doing, going, oh, I added all this other stuff to the assignment, and that's the stuff that makes me happy. But I don't need to be made happy. It's more important for you to be happy with the work you've done on the assignment than for me. So a couple of questions there. Fraser asking if the auto test is passed, but there are problems somewhere else, will it lose marks? Yes. Short answer, yes, but let me explain. If you pass all the auto tests, it means that you've passed a series of specific circumstances that we're testing. A lot of those things that we're testing may give you clues as to what other things we could test. So for example, when I talked about that easy example of the bounds of the map, so you can go above, below, left, or right on the map. Am I doing that the right way? Left, right? I don't know. I'm trying to look at my camera view at the same time, but that's a dumb idea. That's just going to get me in trouble. I'll just mirror myself and get confused. So, you've got the bounds. We might test up and down and left. So let's say we only test those, and you pass all of those, but you didn't check the other side. You can guess that we're probably going to put tests there for the other side to see whether you were thinking carefully about the specification itself, so the document that says these things should do this, and these are the conditions under which they should work. So we're going to say that for each stage. Each stage says this is how this thing should work. This particular operation works in a particular way. Sorry, someone's come to say hello. The reason why people actually came on the stream. Yes, hello. Yep. I don't know if you could hear her, but she was being very vocal for a second there. Say hello. Aww. She's just been asleep all afternoon, so this is her waking up and being angry. Okay. So yes, tests that are in the auto tests are not going to be the same tests that we're going to mark you on. And we're going to mark you on correctness of your code based on what is in the specification, and also what you can check is against the reference solution. Because the reference solution will always pass our tests exactly. So we're going to test you against something like the reference solution, because the reference solution is what we consider to be a correct solution for the assignment. If you notice anything, and especially because we're in early days at the moment, we've still got 2 weeks to work on the assignment, although I think all the bugs are ironed out already. If you notice anything in the reference solution that appears to contradict something that's in the specification, please let us know on the forums. You can say on the forums, or you can email the CS1511 address. I think forums is better, because everyone else can see it there as well. And then we'll make a decision about which one of those is correct, whether there's a bug in the reference implementation, which is unlikely because we kind of did that first, and then we wrote the rest of the assignment around it. Or there's a subtlety that's not being written in the spec properly, in which case we will update the spec. It's unlikely that we're going to do any more updates on it because it's pretty solid at the moment, but if you do see something that's a little bit weird or different in the reference solution, feel free to bring it up with us. Like, this is a standard thing with software in general, is that we're going to make software, but it's never quite going to be perfect on release. If we were to make every piece of software 100% perfect before we released it, you'd be waiting a long time for anything that you wanted to use. So we haven't done things with this really rigorous level of correction, but we're pretty sure about it. But we're also totally open to someone finding something that's a bit odd and then us correcting it. Okay, QWERTY has some questions there. We'll hang on to those questions, QWERTY, because I think we'll look at those in a second. Jet's asking about style. If you want to have a particular style that you want to use over the entire assignment, then I would say yes. Try to be consistent over the entire assignment. So if you want to use snake case and you think the whole assignment should be in snake case, which is fine because that does not break the style guide, then maybe you do want to go through and change all of our variables. I don't think there's that many of them, so that's probably not too hard to do. Or if you want to, you can say, this project was given to me in camel case, so I will continue it in the style it was given to me. The only ruling that we have in terms of how we're marking it at the end is that it is readable and it does not break our style guide, but our style guide says you can use either style. Um, yeah, okay. Let's talk about the marking here because I've got this slide up at the moment, and we're going to talk about what constitutes what level of completion for the assignment. So close to a pass, and anything below this is less work done than this, is what we consider to be like a genuine attempt at stage one. So trying to get stage one going, but not quite getting there. But if you made a genuine attempt, we're not going to take so many marks off you that you can't still pass the subject. We're going to think of it as something that that means there's more work that needs to be done, there's more study that needs to be done, but we're not going to tank your entire subject by giving you 0 for it. So we're still going to be giving people marks that are pretty close to 40 or 50, so you're not hamstrung in the subject at the first assessment if you didn't really know what was going on yet. You've got a chance to catch up. And this might be maybe the ability to place some of these stones, but not necessarily the ability to actually continue onwards and take in commands and get them working or not. Or you can do some of the simple commands. If you notice, if you read through, some of the things are easier than others. So for example, moving the moving the player back and forth is reasonably easy. So maybe you could get that one going even if you can't do some other parts. And so that way you can say, look, I'm trying to get an understanding of this, and I've put an honest amount of effort into it. We're not going to put you in a situation where you're risking failing the subject at that point. If you actually pass, then we're looking for something where the whole thing compiles and runs. So baseline, right? Baseline, the code that you submit to us compiles. And we should be able to reach this baseline because, as I've said before, if I delete all of your code, it's going to compile. So we do say if we're going to give you a pass, then we want at least that basics. We can help out a little bit with this. So if someone has an assignment that's like, it's really complete and it should be like, I don't know, a distinction or something like that, and they've made some final mistake, a little error, and they've accidentally had their final submission or something that doesn't compile. But if we change that small error ourselves, we see that it does compile and it does pass a lot of tests. We're still going to give you the majority of the marks for that. We're definitely going to take some marks off if you do submit something that doesn't compile, though. But it won't necessarily be like all the way down to 0 just because it didn't compile, if there's a lot of work in there that would work. So depends on the severity, basically. But to get a passing mark, we want code that runs, and again, genuine attempts on the assignment. If you've completed stage 1 and you are dealing with multiple commands in a row and completing all the marks in stage 1, then you're going to get a higher mark here, so you're going to get into the 60s or so. But to get the bare 50 for stage 1 for the assignment is going to be I think the main parts of stage 1. If I go to, I think we've got the actual assessment here. If we can scan in input and make changes to the map, as well as being able to fire the laser. So this is us saying that you need to be able to read in input, change the two-dimensional array, and also do some level of looping through the array. The firing the laser involves some kind of looping, I guess, because you're going to be moving through the squares of the array. So if you can do that, that's a little hint actually, you can have that one for free. If you can do that, then you can get a passing grade. When we also look at these marks, there are marks for style in the assignment. So how readable is your assignment? How easy is it to look at it and modify it and things like that? So not only will our tutors see the output of 1511 style, so that's the same thing you'll see. You could consider that an auto test, but that one you can definitely see that it's not a full test, because you could write complete gibberish for the names of variables, and 1511 style is not going to know that they're not real words and they don't make any sense. Whereas a tutor's going to look at that and say, that gibberish is very bad. You need to think more about your variable names. So there are marks to be earned for style in each of these as well. So we're thinking that close to a pass, you may not know that much about style. You may have just been struggling with the technical side of things, and that's sort of similarly what marks you're going to get. A pass, we're going to expect some style, so some structure, some comments, and some correct variable names and things like that. When we get up into the higher levels of doing things, we get into the what you would consider in a university course to be your bonus marks. So you have shown competence if you've passed, and then if you get into the higher levels of credit, distinction, high distinction, that's showing that you can go beyond the basic competence and show the ability to do more stuff. So a credit is if you get into stage 2 and you start working on stage 2 things. So if you've completed all of stage 1, you're moving on to stage 2, and you're very confident of stage 1, then you will probably be getting a mark over 65. Depending on how much of stage 2 you do, this is a pretty big range between 65 and 74. You will get more or less of those marks. We're also looking at this point and seeing that your code is reasonably readable. Also, in order to get into the credit area, we want to see some use of functions. So I don't think that's that much to ask, because I've already shown you at least one example of how to completely clean up a main file so that everything is in functions. You don't necessarily have to go to that level, especially at the credit level. You're probably just going to be saying, some of this stuff has way too deep indentation, I need to move it out. Or some of this stuff needs to be done multiple times, I should put it in a function so I can just call that function multiple times. So some simple things like that, some use of functions is good. Distinction is if we can complete both stage 1 and 2 and we've moved on to stage 3. You can see the pattern happening here. Stage 1 is a pass. Completing stage 1 is a pass. Completing stage 2... Doing part of stage 1 is a pass. Completing stage 1 is a credit. Stage 2 is a distinction. Stage 3 is going to be a high distinction, and stage 4 is going to be full marks for the assignment. So it's just split up in those stages among the marking bands like that. So for a distinction, we're looking at complete implementation of stage 1 and 2. If you've worked on anything for stage 3 and 4, it's still reasonably sequential that I would still suggest doing stage 3 before stage 4, but it is possible to do some parts of stage 4 without stage 3 if you want to. So if it ends up that you have a good idea for something in a later stage, once you've done stage 1 and 2, it's possible. I think it's impossible to do stage 2 without stage 1, and it's impossible to do any of stage 3 or 4 without having stage 1 and 2 working to a certain extent. So jumping around the different stages is not going to help you that much. We have put them together in order. It makes it easier for you to go through the stages in order. When we get up into a distinction is someone who we would say at the end of the course really knows what they're doing. I'm not just saying someone who has got the competencies that we're looking for, and credit is like can go in above and beyond a little bit, but a distinction is like someone really knows what they're doing. So at the point where someone has a distinction, that's someone who I would expect that if you were having a conversation in a lab, they'll be able to actually teach other students about what's going on in the lab. So this is the level that we're testing when we're getting into stage 2 and 3, that kind of thing. The further you go into this, the closer you can get through this range, closer into the 80s you can get. We're also expecting at this point for your code to be easy to understand if we look at it, and very readable. And then we're using the functions well to separate code now. So at this point we're looking for someone whose code is starting to look a bit more like the lecture demo code and stuff, where it's easy to see how the functions were separated for a reason, and it's a good reason. We're not necessarily going to be you know, picking at it too much, but we want to see that it's been used well. The top level for this is a high distinction. So as I said, this is another stage complete. So if you've completed all 3 of the first stages, you're probably, I'm not going to say guaranteed, but you're probably looking at a high distinction depending on how your code is laid out. So I'm going to say this here, if you're pushing for these marks, then that means you're pushing for a very, very high mark, an unnecessarily high mark, depending on what you want to do with your degree. I say unnecessary because, or actually it is it's entirely unnecessary, but for you it might be something that you want to do. You know, if you're someone that really wants to try to push to do the best you can, go for it. Bear in mind that getting an HD in COMP1511 and failing all the rest of your subjects is not an advisable path that I would say you should take. Selfishly, I say definitely, but looking out for your best interests, look after your whole education, not just your computing education. Unless you're a computer science student, then just hammer it. No, you still got to do your maths. They're quite important, you know. Anyway, so we're talking about a complete implementation of the first 3 stages, and then working on stage 4. The more of stage 4 you can do to get close to 100%. Tom knows me because I say this kind of thing all the time. It's like, this is what you should do. As your lecturer, this is what you should do. As Mark, I think this is the most exciting thing ever. You should totally do this. Right, so I'm always going to go a bit back and forth like that. The thing that I usually say for readability and code style for a high distinction or higher, someone's trying to get like maybe full marks in the course, what I would say to you at that point, Tom says he's also not followed my advice. Well, have you followed my advice but not my lecturer advice? Or the other way around? I'm not even sure. I think that Tom gets more excited about things and he writes a lot of code, more than he needs to the detriment of maybe some of his other subjects. Anyway, if I was going to say one thing about what someone's code looks like if they want to get an HD or full marks in an assignment, is it is code that I could put up on slides and teach from. So what I'm looking for is as close to perfect style as possible, with things being explained properly. And I don't want people to fall into this trap, because I know students sometimes fall into this trap of like, how do I make my code fully explained? And they write an essay in the comments. I don't need a full essay in the comments. I know, because I used to do this as well. I used to have a file that was like 3/4 blue comment text and then some code in between. We want the comments to be read, which means we want them to be read at the right time, and so we don't want to get too heavy-handed with them. I mean, I'm more than happy if you're in a situation where you're not sure how much to put in comments, to put more rather than less to start off with, definitely. But if we're looking at someone trying to get full marks in the course, then I want your comments to be really direct and clear and not have to do a whole paragraph of stuff to be understood. Yeah. Okay. So that's the kind of marking scheme. The way that your assignments will be marked is, first they'll be put through an auto marking round, which is the same thing that we would do with your lab exercises. But the second round will be a hand marking round where your tutors will be marking your assignments. So the first round is just a battery of tests. And so we'll get a mark out of 80 for that, which is like, what test did you pass? That's because 80% of the marks for the assignment are for performance and 20% are for style. Then your tutors will look at it, and if there's any problem with the auto marking at that point, they will pick that up and they'll see whether it needs to be remarked. So that's an example of like someone who's obviously written a whole lot of code and then gets 0 in the auto marking, and then we look at that and go, that can't be right. And if someone's made a minor mistake in, like they've accidentally changed the output function, which you probably shouldn't do because we're marking you on the syntax of the output function, but they've changed the output function for some reason, and it's causing them to fail all of the auto tests when they've actually written functional code for a lot of it. that's the case where we would intervene, and we're not going to let the robot give you 0. So we would look at things like that. And then what the tutors are going to do is they're going to read your code, and they're going to look for variable names, they're going to look for comments, they're going to look for indentation, they're going to look for big chunks of code that should be in functions and things like that, and they're going to give you a mark based on how easy it is to read your code. So it's very often that a lot of the tutors are going to mark code by skimming it first. So they'll just go blah, 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 blah. They won't try to read all your code. They'll skim through, and if they get a good understanding on the skim, then you know that your code's quite readable, because it means that you've drawn attention to the obvious places, your function and variable names are really easy to read, and things like that. And then if they need to, they'll go deeper in that, and they'll give you some feedback on some of the issues that might be there. 1511 style will also be run on it, so 1511 style might even leave some comments in your code itself and say, okay, these are the things that that have happened. Your code file will be returned to you, in a sense, after the marking's finished, with a whole bunch of text in it. So it'll tell you which tests you passed and which you didn't, what they were for. It'll have comments from your tutor saying, okay, what was good or bad about the assignment, what you could work on next, and there will be comments in the code itself that says these are the things that you might want to change for next time. Michael's asking, can we ask our tutors to look at our assignment code and give style feedback? Can we ask the help session tutors the same thing? Yes, you can. We're more than happy for you to want to improve before the assignment is finished. So, and this isn't just assignment code. You can bring any code you've written to a help session or to your tutor. Well, I mean, don't bring them your JavaScript code, because we don't even know if all the tutors do JavaScript. Like, this is specifically, we hire the tutors based on what C they write, not necessarily other languages. But yeah, Tom's saying this is interesting. You can totally do that, and almost nobody ever does, because doing that is like getting free marks. Because, like, okay, Tom says you can bring your JavaScript code to him, but yes, you can bring any code you want to the tutors, and you can ask anything you want about it. So you can say, I'm not sure about my style. Is this or this better style? So you could even bring 2 different files to your tutor of the same code and go, I styled this one this way and this one this way. Is there a particular preference? And so your tutor might say, I don't really have a preference either way. A lot of people have questions about how to break up long lines. And I've shown you one method of breaking up long lines, which sort of fits with the syntax of other things that we do. But you can do it in different ways and still be correct. So talk to your tutors about it. They will give you some feedback. And this, if you're chasing marks, there's nothing better than getting feedback from the person that's going to mark it before you hand it in. It's easy, right? Speaking of which, I like this segue. I like this because, Michael, you have helped me segue onto the next slide. Free marks. How do you get free marks? You can write code that doesn't actually solve the problems in the assignment. So you can write code that you had a lot of trouble with, and you weren't sure if it was working or not, and it kind of passed some of the auto tests, but not all of them, so you're not really confident you're going to get that many marks from it. But you can just take like 5 minutes to get it to lay out really nicely and be really readable and understandable, and then you'll bump up your style marks. Cheers, Michael. Yeah, so yeah, you can totally bump up your style marks like that, which is a good thing to do, because we're not just marking you on whether you can get code working or not. What we want to train people to be in this course is not just coders. I mean, you are learning to be coders, but we want to train people to be effective professional software engineers eventually. And one of the most important things about being an effective professional software engineer is that your code can be used by other people as well. So you could get marks on this without getting other marks. So you can get this situation where you're barely getting to a pass, and then you style it really nicely, and this will bump up. And then you could potentially, if you're getting like just on 50, but your style is perfect, you might even be able to go past a pass and into a credit, right? So there's a lot of value in that, and it's not just like It's not just random value, this is real value in your programming skills. You note the difference, right? 20% of the course is in style marks. 20% is the difference between 85% high distinction and 65% credit. So that just shows you how important we think it is, that it's worth as much as like stage 3 and 4 put together. Sort of. So think about that, because that's an important way to get marks, which is my way of saying I think it's important for you to learn, so I've assigned marks to it so that you will to try to convince people to do it. Because I know there's plenty of people. I know there's plenty of people who are here genuinely to learn something that's gonna help them in the future. But there's also people here who are like, I'm just gonna get all the numbers. I'm gonna get the highest number I can, because it's really easy to gamify your life if there's just a score. There's just a score for it. So it's like, the last 10 weeks, this is my score for the last 10 weeks. So if you want the score, it's here, free marks. And if you want to learn stuff, good code is the same thing. Sam's asking if the live stream will be posted. Yes. A few people have asked already if this is going to be recorded. Yeah, it will be. I should remember to say that in the future, now that I've been asked that by a few people. Apologize, I should have said that when I announced that I was doing this. Roy's asking, when commenting on what functions do we do it at the top or the bottom where the bulk of the code is? We usually do it where the bulk of the code is. Some people will put comments at the top, but I think personally that gets a bit messy, because the top doesn't give you enough space to really talk about the function. Whereas if someone really wants to know how something works, they're probably going to be having a look at the code itself. So down where the code actually runs is a decent place to have, like I was doing it previously, those 4 or 5 line comments. Let's just... I closed VLab. I don't know why I closed VLab. I had it open before I started. Show you an actual example, which I think is easier to look at from the last lecture. My font has shrunk a bit. I have a reason why my font has shrunk a bit. I'm going to use that to show off some of Freefall. What's here? The Jumbler. So we have our functions here, but then each of the functions has some code here that says what they do and maybe what they return and stuff. And so if I had all of this up there, that would mean this section here would be about yay long, and that's a bit much for what we want from that. So we don't necessarily want all of the comments up there. We want people to be able to find this main quickly and start to think about it. Okay. All right. So good marks can be gotten from doing style. So if anyone wants more challenge, I will move myself out of the way. If you've gone hell for leather, you've already completed the assignment, and you're like, I want to do more coding, Freefall excites me and things, there are other things that you can do if you like. So a lot of these things require learning that goes beyond what we've taught in 1511, but they might be interesting. So if you want to, you can make a different output function that uses colors, ASCII art, or stuff like that to make the game look more like a game. This could be, you could take a leaf out of Dean's book, who wrote the arcade version. I mean, you don't have to go into full real-time like that, but it could be something interesting. You could write a function that randomizes the starting stones, so you can just put lines of stones wherever you want with some randomness. You could write something else that takes arrow keys and spacebar and other keys depending on the things like gravity storms and stuff like that as input, rather than just the numbers that we had. This one's pretty hard, by the way. There's a lot of fiddly stuff going on there. And then I put this one with a question mark because this one is super hard, and I don't really expect anyone to do this, which I know is for some people a challenge. It's like I've just thrown a gauntlet down. Make this thing multiplayer. I'm not even sure how it would start. But I do know, I mean, like, it's not like I haven't written networked code before, but it could be quite funny if you could actually get this thing to go across a network. Or if not, you could actually go for local multiplayer and have two players controlled at the same time. I think that one would be much more possible. But other cool ideas, anything you want to do, you want to play around with, feel free. We have the cs1511.challenge email address. You can email us ideas in that if you want to, or if you've completed something like this, feel free to email us, and we'll have a chat about the interesting things that you've done, because that's pretty cool. Quody is asking, how do you make it able to put in as many numbers as you want depending on number of lines? Because I don't want to keep adding %d symbols all the time. Tom's saying you do have to have a few %ds, but you can put them in a loop instead. Yeah, because when you think about it, you're reading in one line, yeah. So you can say how many lines of stones there are, and then you need to process 4 numbers for each line of stones. So it could be you process 4 numbers, but you put that in a loop and you do it multiple times, which is, I think, exactly what Tom is saying there. So think about that. There might be ways to do that. You may want to go back and have a look at some of our looping code, have a look at some of the... I've got a scanf demo in the lectures that might give you some information about how we might want to take in input multiple times. And Michael, yes, the extra challenges do look a bit masochistic because there's a lot of work in some of those. They're completely optional, obviously, and there's not even any marks for them. Yeah, I said yeah. Stage 4 takes a lot of time. Don't sacrifice your other courses for it. But here's a whole bunch more stuff that is way harder than Stage 4. Actually, depending on how much time and effort you have spent looking into what the different libraries in C can do, some of these are easier. I think that this one here, if you wanted to do it an easy way, is easier than Stage 4. It just includes content we haven't taught, so I wasn't going to put it in the assignment itself. But learning how to use a random number generator is not that hard. We're going to teach it later though, so don't worry. The output function with text colors and things like that, also, if you can look up some libraries on how to output specific characters, I think that one's also easier than Stage 4. So some of this stuff is just cool add-ons that you do because they bring this thing closer to the idea of the game that it could be. Okay, so that's the end of the slides that I was going to talk about. One thing... Yeah, also, as Tom's saying, do the assignment first. The fun bits that don't get you any marks are not as useful to you as the assignment that actually does give you marks. And that's not just because of the marks. That's because the things that we've put in the assignment are the things that train you to use structures like arrays. Mostly arrays and while loops for this assignment, and the more of the actual assignment questions you do, the more training you get in those things, and the easier it's going to be to do them in the future when they get weird and complex. Because Stage 4 is a little bit weird and complex, but if you were a computer science graduate and I'd hired you to do some work, I'd expect you to knock over something like Stage 4 in like 15 minutes, you know? So this is the kind of thing where it's hard when you haven't learned as much yet. But if you've got a few years under your belt, then this stuff should be learnt by then. Well, I would hope that a 3rd or 4th year graduate would be able to do a first year assignment, especially the first assignment. Len is asking, are we able to look through what's in the different libraries in our VLab terminals? Tom says he thought there was a cat behind him. No, it is this cat. It is this cat who is starting to become very hungry, but I don't think she realizes that she's going to get fed on the stream again tonight, so we'll probably feed her in a little break. Are we able to... Oh, yeah, Len's question, what's in the libraries? I think actually you can... Let's... Actually, don't use this that much, but if we look up Man, let's see if this actually will do this. Oh, maybe standard IO? Yeah, here you go. Input output library functions that are used via include standard input output.h. Here, the description of what it is. There's a lot of description there. Here are the list of functions and at least a quick bit of information about what each one does. So yeah, you can do this using the manuals. If you want to do it interactively, you can even look up standard input output.h, and there's different websites that will look at it. I don't have any particular preference on these. I tend to just click the first one if I'm looking for something and then see what's there. I mean, I'd be a little wary of this particular one here because it says c++.com, but I think that standard input output in C++ is still the C library. So it's still the same thing. It looks like the same thing to me. I haven't got all of the functions memorized. I don't really ever care to memorize big bulk things that I know I can look up reasonably easily. The other one I think was C, so maybe this one's more likely to be exactly it. So these ones are okay because they've got the defines and other things. So you might be able to actually click on these and get a description of the actual function. So it's probably not too bad to use these if you want to. The man pages are also fine. There's nothing wrong with those. They'll give you the same kind of information. Michael's saying, at what point do functions become redundant? E.g., your main calls on function 1 for some general action, function 1 calls on 2, 3, or 4 for specific things, 4 calls on 5 and 6. Is function 4 worth having for readability, or should you just put functions 5 and 6 into function 1? It depends on the situation, but a lot of the time it is a good idea to split these things up. So the example that I was showing you tried to sort of give you an idea of that we could have a generic swap function, which means we could use that swap function in many different places. So if I wanted to jumble in different ways, or I wanted to use a swap function to, say I was looking at my list and I wanted it to end up in a particular order, I could use a swap function to swap things around so that things ended up in the right order. So this thing is going to be useful in multiple different places, even if in this particular program I only use it in one place, which means it's better to have it separate than to have it as part of jumble. So if I had made a function that was just really huge, all I've done is taken the problems that were in my main and I've moved them into the function. Whereas what I probably want to do is, at every level, have everything nice and smooth, in a sense. So this is doing one thing, this is doing a different task which is at like a higher level, where it uses this thing multiple times. And rather than rewriting what's in swap nums, I just use the function here. These other ones, more obvious, read inputs and print nums, these are the ones that I think that you will be able to figure out yourself, because they really have very specific ways of working, and so they just do the thing they do, and then they don't have to do anything else. I'm going to turn the camera because she's just sitting right here. Somebody's hungry. Yeah, so I think when we're splitting deeper into functions, don't be afraid of splitting further in, because you can, and it's okay to do that. Okay, I'm going to take a little bit of a break, a little bit for my voice. But I give you a little treat. We'll do another chicken feeding in the break here. So let me just, I've got the camera on a stand this time, so I'm going to put it down here. Can you see? Yeah, you've just got random stuff in my room there. And you've got chicken herself. I'll be back with chicken and her food in a moment. Is that showing her? Not quite. Hello. Okay, I'm going to bring the camera back up now. Now that I've finished milking my pet for views. Although, I don't think there's anyone viewing that isn't a student anyway. Okay. Back to me. Shrink that back down. So, things that I can show you that are going to help with the assignment. I've already done this, but I will show you. Here I've got all my directories, and I've made one here called Freefall. So I'll just go change directory to Freefall, and I've got freefall.c in here. Actually, you know what I'm just going to delete this first. So let's say I've just created a directory with nothing in it, and this is where I want to work on the assignment. I do suggest that for different tasks you change, you set up new directories, because that way everything's nice and organized. Sorry, just trying to make my camera level. Everything's nice and organized if it's in separate directories. We know where we can look for things if we want to. So there's a command to get the code into this directory from elsewhere in CSE. And so if we go to the assignment spec, it's at the beginning here, start a code. I can actually grab this if I want to. Just going to Control C on that, and I'll be able to right click in here and paste. That will copy, do an ls there, and I've got freefall.c. So gedit freefall.c, and here I have the files that I will need to start working on this. So I was showing you in the lecture, I think it was yesterday, that we have to do, and to do is often a way that we remind ourselves of what's going on. Yes, Jason, this did start at 4. Did you just join? I went through some slides that just talk about the formality of the assignment and stuff like that, so you can always go back and rewatch them. In fact, you've come to a good time, because you could actually consider this and that to be two completely separate things that could go in either order, and it doesn't matter. So yeah, I've got to-dos here, and these are going to be like, what are we going to do? That's why it's called a to-do. It's actually usually what do we need to do next, but and some information here on what to do. This is not all of the information that you need to do the assignment. Most of the information is in the spec, and you can check against the reference as well if you want to. If you want to run the reference solution, Freefall reference? I'm pretty sure it is. I think there's an underscore there. It's either reference Freefall or Freefall reference. Yeah, like this, and then you can see exactly how the assignment's going to work. So how many lines of stone? Let me go to the spec and show you what these things actually are. Because the first thing and the most important thing you're going to want to do is actually at least have a quick look through and read some of this spec to see what is actually going to be used. So there's an idea of what the map is, how the arrays are laid out, and there's also like how we're going to take inputs, and then the stages show how things are going to work. So we're going to put the stone in, and we have information here about what the 4 integers for each stone is. So row and column is where this thing is going to start. Length is how wide this row of stones is, and then the value is the type of stone it is. At the beginning there's only one type of stone, but as you go further in and add stages, you can get different types of objects that appear in the map, and they will have different numbers. Yes, Tom's correct. I expect we're going to be going for an hour. So yeah, so if I'm running the reference solution, I can say, let's say there's 3 lines of stone. First line of stone starts at 1, 1 and is 5 across. For the moment, all the stones are just going to be 1s. The next one's going to start down on row 4. Maybe it starts at 4, 5, and it's 8 lines long, and it's also of 1s. Last one's going to start at, say, 6, 1, I guess, and it's going to be 12 along, and it's going to be lines of 1s. By the way, this input didn't have to look like this. I could put these numbers in any kind of layout that I want to, and it will still take that input. Okay, so 1, 1 with 5 1s. So 1, 1 is here because 0, 0 is the top left corner. 1, 2, 3, 4, 5. So there's 5 of them, and they were the number 1. This one is 4, 5. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5 is where it starts. And there's 8 of them there. 6, 1, and 12 of them. So this is row 6, column 1 of row 6. And it builds a line that's 12 along. So it's up to you to write the code here that is going to, after that, how many lines of stone, figure out how many lines of stone it is, and then ask the user to enter the line of stone. And this is the first slightly complex thing that you have to do, the first major part of stage 1, which is read in these 4 number codes, and you know how many of these 4 number codes you're going to get because you did ask how many lines of blocks there are going to be. And then, based on what these numbers are, make the changes that you need to in this 2-dimensional array. So, a brief hint on how I would go about this is I would do 1 line of stones at a time. I would not try to say, read in all of these and then figure out where all these stones are. What I would probably do is I would just read in the first 4, change the array, then read in the next 4 and then change the array. Because that way what you can do is you can have this whole functionality for each line being put into the array potentially being its own function. Or even if it's not its own function, at least it might be in a loop and then you can do it multiple times. And you already know how many times you're going to do it because the user has typed in how many. I'm not going to write any code. I've made this mistake before, writing code that was too similar to the assignment, and then everyone's assignments got flagged for plagiarism because they were using my code. So I'm not going to write code like that. Quoty's asking, how do you loop the scanf of the numbers? Do you need EOF? You don't necessarily need EOF because you know exactly how many numbers you're expecting to get. Let's have a quick look and see if the spec is going to say anything about invalid input. First number scanned in, number of coordinate pairs specified, will always be valid. Oh, they're not coordinate pairs, by the way, they're coordinate sets, but you know what we mean by that. Will always be valid. It's possible for the first 3 integers, row, column length, to result in a line that is partially or wholly outside the map. If this is the case, you should ignore the line completely and not make any changes to the map. Okay, that's something that we need to know. You can assume the 3rd integer length will always be positive. The 4th integer can be assumed to be valid. For this stage, it will always be a 1. You don't have to check this. Okay, so the information that we're getting from this bit here about the invalid text is that we're always going to get 4 numbers for each line. So if it's always going to give us four numbers for each line, so that's what we're saying is it's not necessarily a human typing these things in and can make mistakes. What we're saying is that when we test this thing, we're always going to give you 4 numbers for each line, in which case you know how many numbers you're going to scan in, because you already know that you're going to scan in 4 numbers for each line. There are situations where you may want to reject those numbers that you're given, but yeah, you don't necessarily need to read until an end of file to do a single input. In fact, given that we have said you first read in how many lines of stone there are, then you read in the numbers for the lines of stone, after you've got your first input, which is the number of lines there are going to be, you know exactly how many numbers you're going to read in to set up the board the first time. So you don't have to do anything strange in terms of reading input for that first set. That first set is like if I gave you a lab exercise, and the lab exercise was output the value of the nth variable in an array, and the input to this is going to be the n number that you have to do. If I was doing that, what I would do is I would read the first input and say someone says I want the 7th element of the array. So I'd go, okay, you're asking me to give you the 7th element of the array, so my loop into the array will run exactly 7 times, and then it will give you the output that it gets to. I mean, like, it's easier than that. I could just address the 7th, but I'm trying to do an example that loops. So I would loop through 7 times until I reach this point, and then I would go, okay, here's your output. So this works in a similar way, where you can say how many lines are there going to be. That's exactly how many times I'm going to go through a loop which puts a line into the map. I'm not going to go deeper than that, right? Because otherwise I'm going to start solving the whole assignment for you. I can get excited about these things and start talking about different algorithms and how I do things and how I'd make things more efficient and stuff. If you want to get involved with that kind of thing, check out the electric car challenge that's in this week's lab. So that's got some thinking in it about how we could push further into trying to do things in an efficient way. We're not really teaching that, but it's something that some people might be interested in. Okay, so the reference solution is always going to do things the correct way. We can always check our stuff against it if we want to. We can run our own solution, run the reference solution. As Tom's saying, check it out if you have time. If you want to, you can always kind of prioritize how you do things. Like university, if you stayed till the end yesterday, you'll know that I kind of went off on a tangent about how marks are kind of arbitrary. University degree is kind of arbitrary. It's not a proof of capability or skill or anything like that. Your WAM is not a proof of your capability or skill. It's just that you scored highly at this point in how you did things. But if you want to, you can get strategic about getting marks, and you can look at how many marks are available for the assignment versus how many marks are available for a challenge exercise. So in a week where there are, I think, 2 challenge exercises, if I remember correctly, this week, then they're worth about 0.3 of a mark each for your 100. If you have 100 marks in COMP1511, they're worth 0.3 of a mark each, and they're only worth anything if you didn't complete the whole lab already. So if you've already completed the whole lab and you do some challenges, they're actually only worth anything if you miss labs later, like you get sick and you miss a lab, which is kind of hard to do because they go for a whole week and you can go to a different lab if you get sick. Like, we're okay with that. We don't want people to miss out on teaching if they get sick. So the challenge marks are worth very little, whereas the assignment's worth 15% of your total marks. So looking at getting higher marks in the assignment will nearly always be a better use of your time than the challenge. You can still look at the challenge if you want to, especially if you're reasonably confident of how you're going to be coding and you know you don't need to look at the assignment right now. One of the bonuses of this assignment is it's due at the end of the flexibility week, which is like the mid-semester break, which means you will have no lab due at the same time the assignment is due. So there's a little bit of a bonus there where week 6 you can just spend the whole week working on the assignment. There'll still be a weekly test that runs into that week, but it won't go to the end of that week. So you're reasonably free of deadlines when this assignment is due. That won't be happening for the second assignment though, because we don't have a mid-session break at the end of term. But at least this one, it's a reasonably lower pressure situation if you want. Okay, so this reference is like if I'd run a program that had completed all 4 stages of the assignment. So I can do other things with this. So for example, the command to move the player is 1, and then we can move it to the left or right by 1 step at a time. So it's 1, 1, 1 to move to the right, and 1 minus 1 to move to the left. So this is something we'd have to do as well. It's part of the controls of the game. The reference implementation has everything that you need, and if you do exactly what it does, you've got a very good chance of getting all the marks you need. The difficulty will not be whether you can mimic what the reference implementation does, but whether you can think of all of the possible inputs that are weird and do the right thing with the reference implementation. So I might try to teleport to the right 4, and it's like, okay. The reference implementation doesn't complain. It just rejects it. So I'm still here. I'm in the same position that I was previously. So if I give it an invalid movement command, the reference implementation is simply not going to move me. Oh, we might have details about that here. Moving the player, invalid input. Second integer of the move player command can be something else other than -1 or 1. In this case, your program should print out the map unchanged. There you go. So we can see that the reference implementation is doing exactly what it ought to do. And we want ours to be able to do that as well. So we need to think about, oh, if that's going to happen, then how do I write my code to make sure that I'm only accepting the correct input? Now, we've talked about this before because I've actually done an example. Yeah, Jet saying that they had a teleporting player for a while. Yeah, that can totally happen, right? Because the logical thing when you see a 1 or a -1 is just to be like, oh, we'll just add that number to something else. But then maybe you're also going to be adding the number if it's incorrect. Yeah, so as I was saying, the good thing is, if you look in previous lecture examples, I have done a lecture example specifically on detecting incorrect input and then correcting it. We corrected it in different ways there. You're obviously not going to correct it the same way, because this thing doesn't say to correct the input. It says to leave the map unchanged. So you would do different things inside the if statements there. But the question of whether the input is valid or not is going to be very similar to what I did. I'm not going to go through all the stages necessarily to say how they work or anything, because I'll probably end up solving a lot of stuff if I do that. But they're reasonably self-explanatory in that every stage will tell you what is my command number, what other numbers might follow. So let me go back to one that has other numbers. So one command number and then a direction. So that means I'm going to be expecting 2 numbers here, and then the meaning of each one. So there's even an invalid example there just to help you out. So these are the 2 valid and this one's invalid. So with that, there should be enough information for you to be able to understand exactly what these functions are supposed to do. But obviously, if you have any questions, forums are open for these things. Help sessions are open as well. So starting next week, help sessions will be running Monday through to Friday. So there's help available every single day of the week for the next 2 weeks for you to work on the assignment. My suggestion is the closer to the due date you go to the help session, the more chance there is that it's going to be really busy and you'll be waiting for like, I don't know, like half an hour just to see someone. Because the very last day, like the Friday before the Sunday due date is really, really busy. Help sessions are stupidly busy at that time. Whereas if you were to go to a help session this Monday, chances are you could see someone right away. So as Tom is saying, and he's repeating it on purpose, Go early. Just read, even if you have no intention of working on the assignment, yeah, read the spec and see if anything confuses you, and then go ask those questions. Or, for example, people have been asking questions already here, and that's totally fine as well. SK is asking, is the reference code only for stage 1 or for all stages? The reference code is for all stages. Let's test stage 4. So, stage 4 has marching blocks and blocks above the map, and the gravity storm. The gravity storm is something we'll be able to do. So the gravity storm, if I remember correctly, it's a command that basically turns gravity in a different direction and sucks all the blocks in a different direction. These are diagonal directions as well, because we're not just gonna make this easy for you. This is like just gotta it's got to be interesting. Gravity storm, I think, is the very final thing in it, but we can test the gravity storm with this because we've got our blocks here. So wait, let's go back and see, what is it? 5-1 is left, 5-2 is top left, 5-3 is top right. Let's just do 5-3 and have all the blocks fall to the top right and see where they are. Okay, so 5-3, so it should grab all of this, all of this, all of this, and send them diagonally up and to the right until they hit something. So our lines have now ended up in this particular layout. So what we've probably got is this line here ended up there. This line here ends up about here. It happened to line up exactly with the end of that one, I think. And then this one has done some interesting stuff where, because it's fallen in that direction, it started piling up here, and then part of that line has piled up there, but then part of the line has been kind of folded as it got squished into the corner, and it's ended up in this kind of layout. I'm not going to say anything about how you're going to implement that. It's obviously not easy. There's some really fiddly stuff going on here to try to figure out how this stuff is actually all going to move. I mean, for one thing, I'm asking you to move things in a diagonal direction, so that's not easy. But also I'm asking you to stack things up on top of each other so that they don't disappear and they all take up a certain amount of space. So that's why it's stage 4. You know, you're not going to get your 100% by doing a single loop through something. This is going to take a bit of thinking. But that just shows you that I just went to the very end of the assignment and that stuff's implemented in the reference solution as well. So at no point is the reference solution going to leave you behind and leave you on your own. Or unless you want to change everything into color. So if I wanted to change all of these into black and these into like some brown rock color or something like that, and the player into like a bright blue jet or something, then that's something that you're going to want to do on your own. By the way, please don't, if you want to do extra stuff, please don't submit it via the give system. Because what I'd hate to see is someone who has solved everything really nicely and then added features, and the features stop the testing from working, right? So if you want to do the cool stuff, shoot us an email at cs1511.challenge with your extra stuff on top, but submit the stuff that is exactly the stages working. Okay, I don't think there's anything else that I particularly needed to say. So I mean, I have been answering some questions that have been going along, but let's open it up now. Any questions you want. This is my favorite bit, by the way. The marching blocks is my favorite bit. Also, I love that we have a little animation here for it. The reason why the marching blocks is my favorite is because I showed you at the beginning, this is what these do. So that was a little bit of us just going, no, this is exactly the kind of implementation that would have gone into a game like this. By the way, someone has asked me previously, and it was really funny, this question. If this is a late 1970s arcade game, and if C as a programming language was just being invented around then, and potentially only being used in research universities and stuff like that, what was Space Invaders written in? And the answer to that is Space Invaders is written in chips on a board. So it's literally chips that aren't even programmable chips. They're like fixed chips, and then they do particular things, and then they go into the board. So it's nearly like they were programming directly in hardware to get something like Space Invaders going. Okay, we had a question there. Michael saying, why did you put adding blocks above the map in stage after we've used the 15 by 15 array a ton of times? Oh, in stage 4. So, question... I mean, asking why, it can be very hard to explain why, but the blocks above the map is there to see how well you do when you need to think about things that need to be tracked but aren't in your primary set of memory. This one resonates with me particularly because I've spent a lot of time as a graphics programmer. And when we're graphics programming... It's not a serious question, but you are obviously working on it, and it's obviously difficult. So, for me, as a graphics programmer, the reason this resonates with me is because we have a screen, right? We have one screen, and it has all of the pixels on our screen that have colors in them, and that's how we display things. On our graphics card, there's multiples of those. And one of them might be rendering the geometry in the scene. Another might be rendering the lighting in a scene. Another might be rendering effects and stuff like that. And then we have to piece them together and stuff. And so I like this because it's a similar kind of thing. I'm not going to say anything more on that though, but it's cool. Yeah, and Tom's saying like this is interesting because like you need to. I think someone's trying to get back into the room. Hello. Yeah, there's going to be multiple different ways that you need to program something, and you need to think about how that's going to work. Oh, it's like Tom's saying, because manager walks in and says, hey, we want X. Tom's management is me as well, so what he's basically saying is every now and then Mark will say, when he's halfway through something, no, I need it to be taught this way. And he has to rewrite it. I think that's where the electric car question came from, because I said, I think, I gave him a few days, no it wasn't, it was like 24 hours notice. Tom, I need a new challenge exercise for this lab. It has to use arrays, and it has to help people with the assignment. And it was like, oh, okay. And then he managed to get it done really quickly. Michael's saying he feels bad for game devs who need to rework features now, or just regular devs. Yeah. This is the thing, right? And this is the thing that we get once we start learning how much effort it actually takes to make something. We start to respect it more in that case. And the other thing is, hilariously, the more game development you do, the less enjoyment you'll ever get in games. So I spent a fair time in game dev as well, and now I can't play games without picking apart how people are doing things. One of the worst things you can do is play a game where you could see what you could fix, but you obviously can't get to their source code and can't fix it. You can't house rule a game that already exists. So yeah, things like that. Let's open up. Oh, Tom's telling a story about going electric. I have a feeling this is, you were on public transport, you're working on it. And you didn't go home because you were working on it. Oh, that sucks. You have to walk home after that. It's a funny story. That's actually quite funny because going electric is about making stops, right? It's about making it to certain places. But it's not that penalized if it overshoots, is it? Okay, so let's open this up now. We still have some people here. I think maybe I've already given people a lot of information that they're looking for from the stream. But if anyone has any questions about the assignment at all, feel free to ask those questions now. I don't have anything in particular else that I was going to talk about in this stream. I think this stream was just to introduce what the assignment is, talk a little bit about exactly how it's going to be marked, how it's going to be tested, just so that if you wanted a reference for everything, I had it. But we do have, oh, there's a question there. Jet, for every command, will we always be given the correct number of commands? I know for stone setup it says we will. Let's have a look, because I think this is something that we're going to want to look at, because it's going to be a stage-by-stage thing. So let's just, while we're here on the harder stuff like Gravity Storm, what does it say about invalid input? If the direction argument is anything other than 1, 2, 3, or 4, no changes should be made. It does not say specifically that it won't, but I would suggest that if you put a 5 in and you don't put another number in, your program and the reference solution will just sit there waiting for the next number. Let's actually do it. So I put a 5 in and I press enter. The Gravity Storm command has, I guess, been invoked at this point, but it's still waiting for proper input. So I would have to put a number in for this thing to work. If I put an invalid number, as we see here, where is it? No changes should be made if it's anything other than 1, 2, 3, or 4. So if I do that and then I do this, if I'm putting an extra number in here, let's think about what happens if we get the wrong number of commands. What I'm in now is an interesting state, because I've put a 5 and an 8 in. Putting the 5 and the 8 in will mean the Gravity Storm command has run, but it has not moved any of the blocks, because nothing moves on an 8 and the Gravity Storm. And then I've put a 1 in, which means I've actually put in a different command now, which is moving the player is command 1. So my program now is actually waiting for the second part of moving the player. And if you're doing this with scanfs, it's going to be okay with this. Yours will be doing the same kind of thing. So if I put a -1 in now, I expect the player to move 1 step to the left. And that has happened. So we don't necessarily have to say whether a command will or won't receive the right number of commands, because if it doesn't receive enough commands, it will just won't execute. But if it receives more commands than it needs, that means it's actually receiving other commands. So let me do another thing with the reference solution to show you this. So I'm going to use the move command again, because it's pretty easy to understand. So 1, 1 is going to move me to the right. 1, 1 is also going to move me to the right. 1 - 1 is going to move me to the left. What I'm expecting to happen when I press enter here is that 3 movement commands will happen in succession, which means the first thing is 1 movement command. I should draw another map with the player 1 square to the right, for you the right, and then I will have a second command run, and that will also move the player 1 square to the right, and then I'll have another command run, the third one, and the player will move 1 step to the left. So I'm going to press enter now, and we're going to scroll up to where we put this command in, and our player was here, and we moved 1 step to the right. And then we moved another step to the right, and you can see we haven't given any more input here. There's no text from us. So it's still going through this input here. And then we moved 1 step to the left. So even though what I've done is technically put too much input in for that 1 command, what it actually does is the command takes as much as it needs from that input, and then whatever inputs are remaining here will get taken up the next time that a command needs to run. And that's okay, because that's how scanf works. Scanf, when I type stuff in, it will just take the first things it sees if they match what we're doing. What we're not worried about is invalid input with like text or anything like that. As you can see, I put in text there and it was like, no, this is not what I'm dealing with. I don't think we have any specific thing about text, do we? Looking at Dean and Tom, I'm pretty sure if you just bug out like this because the input is so incredibly invalid, then that's okay as well. I wonder if we say that in the early stages. Inputs and validity. All of the inputs to your program will be in the form of a sequence of integers on standard input. So I just typed in letters instead of integers, and the reference solution said, I will have no more of this. I'm not, that's not part of what the program should do, and so it's okay if yours does the same. We're never going to be testing you with letters, by the way. I just threw that in there for fun. Yes, yeah, Jet was saying that already, that it was going to do that. Okay, after scanning in all the inputs, you will need to scan commands until end of file. So we are thinking that you will keep scanning commands forever until a point where you have everything you need. And Tom is answering there also, where you can do something where scanf, and you test how many numbers scanf has read in. So you could scanf and say, if I've read in the correct number of things, then I don't need to do anymore. So you don't need end of file. You can say, for each command, you scan until you reach the end of this thing, and then you scan another command, and then you can then scan a certain number of integers. You don't always have to do it by using the output of scanf. You can also, if you want to, loop through individual scans of individual numbers. But if at any time you don't get a scan of a number, so scanf should return 1. If it has 1% D, it should return 1 if it read in one number. So anything other than a 1 is an incorrect thing, and so you could just end on an incorrect thing, which I think is what this code is doing in the reference solution. So it's not looking explicitly for end of file, it's just saying I didn't read a number when I scanned F. So I did scanf, user did something, and it wasn't an integer, so I end the program. So whether it's end of file or a letter or an invalid thing, we're just ending the program if we don't get the inputs that we think we're supposed to have. B sure is saying, for stage 2, which way is better to approach it? Make a duplicate array or a loop or pointers? Stage 2, so my suggestion is that pointers will not be necessary for this assignment. So let me just go up here, and we said allowed C features here, but it's like, we strongly encourage complete only features taught in lectures up to and including week 4. The only features you will need to get full marks in the assignment are these: int variables, if statements. Hey, Tom, Dean, we should probably put doubles in here. I think you need doubles at some point in this. I think we need ints and doubles. If statements, while loops, int arrays, two-dimensional int arrays, printf, scanf, and functions. You can get full marks with only these. So I would suggest that if you're thinking of using pointers, be really, really specific and careful about what you want to do with them. Because yes, there are definitely ways to use pointers to do some of this stuff. But bear in mind that I wouldn't start trying yet with pointers until we've at least had a tutorial and a lab on them, and you've got a bit more of an understanding of them before you start trying to throw them into something more difficult like this, especially if we said you don't need them. But you're asking for an approach for stage 2 is to make a duplicate array or a loop or pointers. So stage 2 is shift everything down, or the end conditions. I'm going to assuming you're not wanting to make a new array for the end conditions. But for shift everything down, what you're doing is taking everything from a certain position and then moving it down another position. So what you're going to need to do at that point is read things from an array and write them somewhere else in the same array. I could see a potential solution where you could do it with a duplicate array. I can also see another solution where you could do it with a loop going through. Off the top of my head, I can't see an easy solution using pointers. I'm sure that you could come up with a solution using pointers because they're quite powerful and they have a lot of options, but I can't think of one. In the back of my head, what I would do I would work with a loop, but depending on the context, I could also be convinced to do it with a duplicate array. So I have a feeling that whatever you're thinking, it's highly likely that you're right in what you're thinking. And then you're thinking that there's multiple ways to solve this problem, which you are right about. Every problem has multiple ways to solve it. So I think it's okay, if you want to try either one of those ways, like a loop or a duplicate array, or even pointers, because if you can see a solution in your head using pointers, you can try it. I wouldn't count on it too much with the pointers, because this assignment is designed to be solved without them. We've taught you about them because we're preparing you for the next topics and things, but it's designed to be solved with loops and arrays. So thinking about either making a duplicate array or a loop to do this, I can see solutions that would involve either one of those that would work. So I think it's just up to you to decide what you think is the best for how you want to do it. I can think of ways to do it in the array itself, and other ways. I'm trying to answer your question without saying how to do it, because it's like totally right in my head there going, do it like this, and I'm just like, no, that's really bad. I think it's much better for you to have a chance to play around with the problem solving process. What I think, I don't know if you have time to do this, but the fact that you're talking about stage 2, and we're not even at the end of the first week, means you've already started early, which is great. So I think what could be really cool is you solve it in different ways. So you solve the same question multiple times in different ways, and then you see for yourself which one you like more. Which one's easier to read, which one works in a way that's more understandable, which one are you more comfortable writing. Sometimes the one you're comfortable writing isn't the best way either, so sometimes it's interesting to do the way that you're uncomfortable with. In a different world, I would say work with other people and see if different solutions come up for you, but this is an individual assessment, so you can't do that. So it's unfortunate that you've come up with a cool idea of multiple possible solutions to a problem, because in those situations it can be really good to work in a group and bounce ideas off each other about those things, but not for the assignment. I apologize. But you can think of, maybe in your next lab there'll be something that's similar, where you can think of multiple ways of doing this, and you can say to the people around you, hey, I've got an idea for doing it this way and an idea for doing it this way. And someone else might say, oh, that's interesting because I had that other idea as well. So let's do it in different ways, and let's look at each other's code and see how we're going. Don't do that for the assignment, but labs are open, right? So doing it for the assignment counts as plagiarism, and we really don't want people doing that, because what you end up doing then is taking away learning opportunities from other people. But in labs, I think it's really cool to have different solutions to things and to see how different people are solving things. So you can do that with yourself if you want to, or you can just try one of them, and if it works, you can say, okay, good, now let's move on. So up to you. I hope that answers the question. Are there any other questions from anyone? I'm gonna hang out for a minute or so and see if anyone has any other questions they'd like to ask. And if not, I think that will be enough for our assignment intro live stream. So I think hopefully we'll have given a lot of information to everyone about the structure of the assignment, what you can kind of expect from the testing and how you can use it. Oh, the one thing that I haven't done, which is the fun bit. 1511 Arcade is the real-time version of this assignment that you can run, and you can actually put your own solution into it. So I could do freefall.c here. Is it freefall.c? I think it is, and it will use my code in the solution, which totally won't work right now because I've only got the starter code here. So what I'm going to do instead is say solution, and this will use the reference solution as the kind of data part of the game engine that's happening in the background. And this will run like it's an arcade thing. And in here we have multiple different possible maps that we can use. And if we want to, some of these are actually part of the auto tests, so you can see moving in real time whether your freefall player is working. Let's do the marches because marching's fun. And I go left and right and upwards to fire the laser. Oh, I'm not gonna get there. Oh, damn it! I think I pressed too many keys and it exited. Or I think it exits when it finishes running anyway. But you can kind of see. Oh, we're gonna run that again. How? Oh, no, I've done the wrong one. Arcade solution. So you can see how the code that you're writing that will move blocks around, will move the player and things like that, can be used to actually make a game. So he's on with some lines. And if I, oh no, I should have, no, I lost again. Yeah. But you can see with that, it'll show you how the code you're writing could get put into a game and could get used for things, and it's kind of interesting. So I like that, and don't worry about trying to do anything like that, because that's I don't know if Dean's still here, but I'm pretty sure that one's written in Python. Yufanzu has a question. How many functions are expected to exist to have a good style mark? I have not thought about the number of functions, and this is not something that I would oh, Dean says doubles are not technically required for the assignment. Okay, cool. So it wasn't necessary. I think because you have done the reference solution, so obviously you did it in a way that didn't need any doubles. And off the top of my head, now that I'm thinking about it, I can also see how you can do it without doubles. I don't know why I was thinking we definitely needed doubles. I think it was because of the circle calculation stuff that I thought it might need a double, but I can see why it might not. Okay, what was I going to do? How many functions? It is hard to say how many functions. But if we're talking about trying to get full style marks in things, there's a decent chance that each of these things would be a different function. So placing the stone, moving the player, firing the laser would all be potentially different functions. But so Tom's saying that at some point he mentioned a double in it, but it might not actually need it. Yeah. Okay. So these would probably, but I don't know for certain. I would have to go through. I haven't actually gone through start to finish and completed the assignment myself. I've only kind of done bits and pieces of it. But you could consider each of these to want its own function. But some of them are going to want sub-functions underneath. So if we were going to really specifically say that there was a certain number of functions, possibly it would be the number of these sub-stages. But I think that in reality, for it to look neat, it would want to have more than that. You're going to find that the number of functions is decided by the needs of the program as you're writing it, more than being able to say before you write it how many. As I was saying before when I was talking about functions, this is a nuanced skill, deciding how many functions are necessary in a program. And I'm not too worried if you don't get it right the first time. And this is also something you can take to your tutor if you want to. So you can say to them, I've started splitting certain things off into functions. Do you think I'm using the right number of functions or not? Or do you think that some of these functions are too big? Do you think if maybe you think that some of the code in your main could go into a function, but you're not sure how? Your tutors can help with all that kind of stuff. And so you can get a kind of a bit of practice and experience with learning what needs to go into a function and what doesn't. And it's definitely worth trying for the assignment. It's worth trying and learning. But I don't expect you to have 100% success with it. That's not something that I'm requiring everyone to have 100% success with. Only the very small percentage of people who are like pushing for high HDs, so high distinctions, like marks in the high 90s and things like that, am I really going to be checking exact kind of function layouts and things like that? For most everyone in the course, it's going to be a matter of are you using them and are you getting practice with splitting them out? Have you made some good decisions about when to use a function or not? So I think that's what I would say about that, where it's very hard for me to give you an exact number there. And you will see, depending on how you've solved the problems, whether you need to split things into functions or not. Okay, looks like Tom and Dean are having a conversation about a possible edit to the spec there if we need to. Yeah. And I think that just came from me seeing doubles. Okay, so if there are no other questions, I think I've had it open for questions for a while now. If there are no other questions, we'll leave it there and we'll wrap up the stream here. Thank you all for coming along. This will be recorded and I will upload it to Echo 360 as well so that everyone will have it available. And hopefully this helps answer a lot of the questions about the assignment before people get into the assignment. All right, see you all next week.